Hey everybody, welcome to Module 4. I'm going to try something new. I'm going to offer 50 extra credit points to anybody who turns their homework in. Well, you still do your full homework, but you turn in an Excel spreadsheet with your portfolio part 1 of all of your homework problems done in Excel. I'm going to go ahead and work partially through the problems that I listed up here. This is not your Excel exam, although some of these problems will be on your Excel exam. Your Excel report. All right, so all we're going to do is just use this Excel to take notes and do our homework. All of the problems, numbers 1 through 40. Starting with number 1, all we have to do is write a fraction out of this ratio. The ratio in this case is 4/14. So I'm just going to put equals 4/14 into my calculator over here. Hit enter. Excel gives me a decimal, so I click on that cell. I go to number. I do the little drop down arrow. If yours might say general or number, it might say something different. Any of these things actually. I click on fraction and Excel instantly reduces my fractions to 2/7. All right. On number 2, it's not on my list, but I just wanted to show you guys. On number 2, if you look at the example, it shows you how to cross multiply to solve for an unknown value in an equivalence ratio. That's what this is called. X is to 25 as 6 is to 10. Some of you might say, hey, well, 25 is 2.5 times more than 10, and 2.5 times 6 is 12 plus 3 is 15, and you can just guess that this is 15. But if you're going to put it in here in your Excel, if you're going to turn this in for 50 extra credit points, then here you might put just the start of the problem. You have 10 times x equals 25 times 6. And then on your next line, you divide both sides by 10. So you might say that x equals 25 times 6 divided by 10. And then you can actually just select this part. And these are just warm-up problems, equivalence ratios. Knowing how to do that is pretty much a prerequisite to this class. And then here, all I did was I cut and paste from what I had previously and hit enter, and it gave me my answer of 15. All right, and then you guys would have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you would just keep doing the work for each problem until you hit number 12. All right, and here it's a lot of these questions the author has made nice and easy. He does a number out of 100 so that your denominator is 100. So you actually just end up having to find 45% of 17. And a bunch of these problems are like this. All right, I'm going to skip all the way to number 12 just because I'm going to try to get a few of these out of the way that folks struggle with. I am not going to work the full problem for each one of these folks. I'm trying to keep this video rather short. So on number 12, look, it wants us to fill in this chart. I expect you guys to use this for a bunch of these problems. Here, I'm going to have an x. Don't be scared of function notation. G of x is just the same thing as y. All right, g of x is the same thing as y. It's just function notation. Maybe this is I can't think of anything for g, but we often see like h of t. H of t might mean the height according to the time. Well, I shouldn't have actually done that because we'll actually be seeing that, I think, in number 28, maybe. I don't know. All right, so getting this back to where we were, we had g of x. So my x values in this case are 0, 8, and negative 8. And then my g of x is this function right here, equals negative. I always put my fractions in parentheses. You know, you don't always have to. I like to always do it. It makes me feel safe. All right, so I have negative 3/8 times x. Hopefully you guys know how to do this by now. If you don't, then I would recommend that you go back and do Excel report 1. All right, there I have my whole formula. You guys see that? That's just this negative 3/8 x plus 3. Hit enter. Select that cell. Get a little black cross down in the bottom right-hand corner. And if you have not done Excel report number 3, then you didn't learn this new trick that I just learned last week, where you just click twice and it fills it all in. So before I used to drag, and now I know I can just double click. So now I have my values here, 3, whoops, that's not a 3, 3, 0, 6, and voila, there I am. Uh-oh, what happened? Now it wants me to graph it. All right, so easy enough. I can just select this data here and insert a smooth line scatter plot if I want to. I can actually insert one with marks on it as well if I wanted to. So now I'm just going to draw that graph here. And I really didn't need this graph. It was just kind of cool, so I added it for aesthetics. Not necessary. So to graph this, I just need to grab 2 points. I have a point at 0, 3 and a point at 8, 0. Anytime I have a little chart like this, folks, that simply gives me some ordered pairs. And here I have 3 sets of ordered pairs, 0, 3, 8, 0, negative 8, 6. So I simply click the line. I go to 0, 3. That's 0 on the x-axis, 3 on the y. Does that look about right? I actually have this thing set up so it doesn't have to be perfect. All right, and then I'm going to take it to 8, 0. That's 8. Oh boy. And I got, oh, here, I can see down at the bottom, I can see my numbers. All right, and there I have my line. Check my answer, and I'm good to go, ready to roll, hopefully. Don't worry, I also always hold my breath each time I press check the answer. All right, let's move on to number 25. No, good. Number 25 wants me to graph this parabola. So I'm going to go ahead and, you guys, don't forget, you're doing all the homework problems. I'm just doing a couple of them with you here just to kind of show you, get you started on using Excel to do your homework. I mean, really, if you guys are taking 4 and 5 hours to do a homework set, you're in trouble. Doing these on Excel literally takes just a minute. And that's what this class is about. All right, so it wants me to graph this parabola. So I'm going to go ahead. This isn't an actual story or anything, so I'm just going to go ahead and start at, I don't know, negative 10. I like that number. This is f of x. G of x and f of x are basically generic function notations. So here I said I was going to start at negative 10. That means that my next number is going to be what, guys? Don't say negative 11, negative 9. All right, negative 9. I'm going to select these two, and then I'm going to let Excel get me some values here. And then over here, I'm going to type in my function. It was negative x. Whoops, I need an equal sign. Equals negative x. Don't forget, click on your x value, squared. That's control 6. I'm sorry, shift 6. Raised to the power of 2. That's how you write squared. Plus 5 plus 4. I'm sorry, plus 5 times x plus 4. All right, so now I want to apply that to the entire row. I'm going to select all this data, and I am going to insert. And I can actually see that I chose a good number. I'm just going to kind of point this out to you guys, because do you see where I have negative 2, negative 2? And then from here it goes 0, 0, 4, 4 on each side of that. That means I found my vertex. Isn't that cool? All right, so I'm going to select this data. I am going to insert a smooth lined scatter plot. And looky there. And then I can find my vertex. Well, if I want to find the lowest y value, I can look at my chart here. It looks like the lowest y value is negative 2. So I likely have some point. There's negative 2, negative 2. I'll move that over. And sometimes on Excel, it's just a little bit hard to find the vertex and the x-intercepts and things, which is why I have for you guys, if you go to your Blackboard, let's see, Blackboard, I'm going to go to the module 4 for any one of these quantitative literacies. And hopefully everything's the same. At the bottom of your module 4, you are going to find Symbolab Graphing Calculator. Symbolab is awesome, folks. I'm going to go ahead and copy this formula here since I already typed it out. And you would just type the formula. Let me just move this over here. All right, so you guys, here where I have this B Bravo 25, I'm just going to put in an X because that's what those were, remember? Those were my X values. All right, and this one was supposed to be squared, but somehow that got lost in the translation of the copy and paste that I used. All right, cool. Check it out. Now, here on Symbolab, it is very easy to read. I can clearly see my vertex, and I simply just put my pen, my cursor, right on top of these points. Well, usually I just put my cursor right on top of those points, and it gives me the value. Let me pause this real quick and see if I can figure out what's wrong. All right, so I was not able to click right on usually I'm able to scroll right on the spot and it gives me the values, but I see that it just must be off because there I have my maximum. It says it is 5/2, 41/4. It does say to enter your answers as integers or fractions. So we're going to be real glad this is given to us in fractions. Otherwise, I'd simply put my fractions in Excel and turn them into decimals. So I have 5/2, 41/4. That's 5/2. Oh, 41/4. And for those of you who are still using these keys over here, you could just use your fraction bars, and I just use tab to switch over. And then of course you just kind of hold your breath, cross your fingers, click check answer, and it says that it is incorrect. So you can clearly see I typed in 4/2, but the answer over there on my Symbolab was 5/2. So hopefully that was the mistake. Oh, something's still wrong up here. All right, and just like the real world, the technology doesn't always run very smoothly. All right, now we have a perfectly fine answer. And now it's asking us to show a picture of a graph. Well, hey, no problemo, because what do I have? I already have my graph done. So I can clearly see here that alpha is the correct graph. All right, fantastic, you guys. Symbolab, it's in your Blackboard. Use it. All right, that was number 25. What did I say I was going to do next? Number 28. All right, let's have a quick look. And of course, you guys would have all these on here if you want your 50 extra credit points. And it's not only 50 extra credit points, you guys, but I'm offering the extra credit so that you can see how much easier life can be when you use your technology. Okay, here's one. Everybody goes nuts over this problem. It's just a simple, I know it's not simple, and it's a college algebra problem. But we're simply going to calculate the height according to the time of a projectile motion. In this case, what do we have? How high does a ball go if it's thrown upward from 7 feet above the ground, from the ground level at a 60 feet per second? Well, 60 feet per second is our velocity, and 7 feet above ground is our height. And if you look up here at our formula, you'll see that we have the height. Here's our function notation. Height according to time equals -16 times the number of seconds squared plus the initial velocity times the number of seconds plus the initial height. That's all that little sub O, that V sub O means starting velocity, and H sub O means starting height. Well, negative 16 is also interesting. Negative 16, does anybody know what that is? It's the force of gravity. So this is the force that the object is being pulled back down. All right. Whoa, what happened over here? Something went wrong on my graph, didn't it? Looks like some number got changed somewhere. Huh. All right. So, sorry guys, didn't mean to get sidetracked there. All right. Now, all this is gives us a formula, and now we are simply going to plug it in. This is just homework notes, not an Excel report, so I don't have to do a ton of fancy stuff. I'm just trying to get my answers here. So I have my t, my time in seconds, and then over here I have my height according to my time. I am simply going to, it wants to know the maximum height of the ball. Well, in order to do that, I have to graph the function. Well, I can't graph the function until I have some values here. So is the ball ever going to be at a height less than 0? No. I mean, it could go over a cliff and go down below ground level, but I don't think we're dealing with that here. So I'm just going to go ahead and start at 0. Do you guys think the ball actually starts at 0? Well, where does it say the initial height is? Okay, I'll let you guys think about that. So here, I'm going to just type in my 0 and my 1, select them, drag it down. If this is not second nature to you yet, please go back and do Excel report number 1. You will learn how to do all of that. I know there are a small handful of you out there who have not yet done Excel report number 1. That's okay. Go back and do it. At least get something out of this semester. All right, so now I'm going to plug in my my formula here. Force of gravity, negative 16 feet per second. In this case, we're dealing with feet per second, guys. If we were dealing with meters per second, it would be 4.9. So if you ever see that negative 4.9, that's when we're dealing with metric. All right, so our force of gravity is negative 16 feet per second times x squared. So that's x raised to the power of 2 plus my initial velocity. And what did you guys say that was? 60 feet per second times the number of seconds. That should be intuitive to you. 60 feet per second times the number of seconds that it goes. And then plus our initial height, which in this particular scenario is 7 feet above the ground. All right, I hope you're all out there going, why did she type T when I should have selected this cell? All right, I hit enter. And again, like I told you guys, I learned the other day, I don't have to drag this down anymore. I just get to put my little black cross cursor and click, click. And look at there, everything gets filled in. All right, it looks like I am gonna, wow. These are, well, this is gonna be interesting. Let's have a look at it. I have not done these problems previously. I just jumped right into this. So you guys are just getting whatever I come up with here. So here I'm going to insert my scatter plot with smooth lines. All right. I hope that you guys can clearly see that this doesn't make any sense. Do you see where this goes above 0 and this goes all the way to 1,000? I mean, this is a ball. It was thrown. That means a human threw the ball. Is the ball going to hit 1,000 feet in the air? Not likely. I honestly don't know the stats on how high a person throws a ball. Is that possible? I have no idea. But in this case, that's not what happened. So what I'm going to do, folks, and I can already tell this was going to happen when I looked at my chart. You see where it goes from -9 all the way down to negative 4,629. I clearly don't need all those points because my ball is not going to go 4,629 feet below ground level. So what I'm going to do is instead of counting by 1 second at a time, what would you guys think about counting at, how about, what do you say? A tenth of a second? How about that? What would you say about counting by a tenth of a second? I'm going to go ahead and select those two things. Wow, do you see how it changed everything? It changed my heights. It changed my graph. Does my graph make more sense now? Sure. Because look, it starts right here. And I can actually change my y-axis here um, to count by, I don't know, what do you guys want to count by? Right now it's counting by tens. I'm going to have it go ahead and count by, oh, what do you say, twos? And then I'm going to have, is that going to do what I wanted it to do? I'm not really sure. Let's see. Let me just mess with this for just a second. That did not give me what I wanted. How about that? By fives. That doesn't look too crowded, does it? See, you just kind of mess with it a little bit. All right, now I have another problem happening. Now the problem is that I need to see the whole entire graph. So counting by a tenth was just not quite right. I'm going to go ahead and count by a quarter. All right, so counting by a quarter. Oh, isn't that nice? Do you guys like how that looks? Looks really good. I still went a little too far down. I didn't really need these values. I might keep that -9 just because it at least takes me to my ground level. And I'm just gonna clear those out there. Wow, don't you guys love it? All right, now I have a beautiful parabola. The question here is, what is the maximum height of the ball? And I have to round it to 2 decimal places. Well, the maximum height, look here, you guys. See how it's 63 feet right here on both sides? And then it goes down to 61. Here's my symmetry. And boy, I'm going to get too crazy here, aren't I? I didn't really want to spend too much time, but I can hardly help myself. When you guys look at projectile motion, what happens is your ball is being thrown up into the air. Pretend like that's a straight line. That didn't get very straight. Try it with my finger here. If we get a straight line throwing that ball up into the air, there's nothing to stop that ball except gravity. And what happens when our gravity starts pulling is it pulls the ball down at an exact constant rate. And between the velocity of the ball going up and the gravity, the force of gravity pulling it down, it creates that beautiful parabola. Isn't that cool? But that is not what you want to know here. All you want to know is, what's my answer? So what does it look like it's going to be? Something between 63. You guys want to just try? Yikes, you guys, what do you guys want to try there? You think 63 is going to be it? Is that going to be your maximum height? Or is it going to be 63 and a half? It's kind of hard to say. We can try 63 and a half. You can see that you can actually put your cursor right here in Excel and it will actually give you some points. Is there anything bigger than 63? It's kind of hard to say. What I can do is grab this formula. Where do you guys think I'm going with this? I am going to Symbolab. So right here, where is my Symbolab graphing calculator? I love Symbolab. All right, again, I'm going to have to change these things to X. I think in Symbolab you can really use any letter. I don't think it's discriminatory. All right, here's my parabola. Whoa. Sorry, you guys. I'm trying to move this with my mouse, but it's doing odd things. Let me see if I could do it with my finger. No. All right, so what's going on here is I need to make this smaller so that I can actually see the pieces of it. All right, and we can do a lot of things with Symbolab. You might wish this window looked differently. You just click this little gear if you want to change your window. And right here, my x-axis, I can just go like -5 to, it looks like 10 would be more than enough over here. And on my Y, I'm not really interested in anything below ground level. So I might just hit -10 just to give me a window to see. And that looks like that 69.77 is a fine height. So here, oh, here, now it's working. I simply put my cursor right on that dot, and there's my maximum height. So you have to know you have an X value and a Y value. That means in 15/8 of a second, well, that's actually, what's 15/8? Almost 2 seconds, right, you guys? So it took almost 2 seconds for the ball to reach its maximum height of 253 fourths. Symbol Lab's very precise, so it gives it to you in those fractions. That was 253 fourths. I'm going to go ahead and, where did my Excel go? So right here in my Excel, I'm just going to go ahead and put in equals. What was that? 254 fourths equals 254 fourths. Enter. I'm just going to go back and double check that 254 fourths was correct. I think that's what I said. 253 fourths. You see that? 253. Close, but no cigar. All right, 253. And we all know that Connect Math is not going to give us a break on our decimal values. All right, so I have 63.25. And hopefully that is correct. It takes how many seconds for the ball to hit the ground? Well, look, guys, where does it hit the ground? This, where it says 0, is ground 0. So ground 0, if this was an Excel report, you would have this labeled as height and time. This is ground 0, so that's going to be this point right here. It's giving me 4, -9, but I'm not going to trust Excel on this one, you guys, because I can clearly see that the ball is going to hit the ground somewhere between here. I wonder what happened here. I can just undo. Not really sure what all that was about, but anyway, let's get back to our Symbol Lab. Where did the thing hit the ground? The ball hit the ground right when the graph hits the x-axis. You see that right there? Oh, Symbol Lab gave me a decimal value here, 3.86. So it took 3.86 seconds for that ball to hit the ground. What do you guys think about that? I bet you like it. All right, let's have a look. Did I promise to do one more? Cannot remember. Oh, I promised to do 2 more. All right, let's look at number 37. Number 37, I think, is this going to be the crazy resort guy? I think it is. I'm definitely not going to do this whole problem, but a lot of people have questions on this problem, so I'm just going to kind of at least get you started on it. So here we have a fella, some crazy mathematician, retired from teaching college classes and decided to move to Costa Rica and open a resort. And he's going to charge all these weird prices for his resort, depending on how long you want to stay. So in the first case, it decreases each day. Let's see. In each case, the cost decreases each day, and you have to leave when it reaches 0. So option 1, okay, so you can stay however long, but as soon as the amount you owe is 0, then you have to leave. Okay, that's exactly what it means. All right, so per person, the cost is $300 a day for the first day. All right, so let's go ahead and put this here. I'm just gonna make myself a chart. I'm gonna have the number of days, because isn't that what the cost is going by, the number of days? And this is going to be my cost. So here, if I have 0 days, I have 0 cost. If I have 1 day, what do I have? 1 day, I have $300 cost. Isn't that right? The first day. All right, so $300 for the first day, and in each successive day, you subtract 10 times the square of the number of days that you've been there. All right, so after the first day, now I'm on the second day. I'm going to go ahead and get myself a little thing of days going here. I'll just go to 16 days. All right, so let's see what the heck is that crazy thing that he just said. $300 the first day. And then I subtract 10 times the square of the number of days you've been there from the previous day's cost. All right, so that means that the second day is going to be the previous day's cost. So I'm just going to click that cell, and then I'm going to subtract. I know it sounds crazy. Take it one step at a time. 10 times the square. So that's 10 times this number, whatever this number is, 10 times the square of that number. Okay? So, do you guys see what I did? I took the price of the day before, which was $300, and I subtracted 10 times the square of the number of days that I have been there. All right. I'm actually going to probably look at the example here because I'm not sure if it wants me to say that I've been there one day and subtract 10 times the square of one, or does it now on the second day want me to say I've been there? I'm not sure. So I'm going to look at the example, which is what you guys are supposed to do. That's what this class is about. It's not about knowing how to do everything. It's about being able to use your resources and trying to figure stuff out. My lab is logged out. I'm going to pause the video. I'll be right back. All right. Let's just keep rolling here. I looked at the example, and it does look like it's just going to count that day before. Here, the example is actually different from mine, but on this one it has that was 400 minus 10 times 1 squared. So I can clearly see that this was just 40 minus 10. Okay, so that's how now I know that I'm just going to do it minus 1 squared and not 2. If you don't know what I was talking about, then just follow my example here. We $400 for the first day. I'm sorry. Did I get a different problem? $400 the first day, and each successive day you subtract 10 times the amount. All right, so everything's the same, but it looks like this one is starting me off with 400. I don't know if that changed or if I just didn't notice it last time. All right, fantastic. Now I have this pattern going. And hopefully you guys can see that I can't stay here 10 days. I can only stay at this resort for 9 days because by the time I hit the 10th day, I went below 0, and I'm not allowed to go below 0 here. I'm just going to look at that example again and make sure that they have some kind of so they just put in 0 for every day after that. So on this one, what did they get to? They started at 400 and they went down to $100. And it looks like we go down to 403. Let me just double check my formula here. All right, minus 10 times that number squared. Make sure this is applied all the way down. All right, there. Now we have something that looks similar. So I just had a little something wrong, and it's always good to go back to the example, look at your work, and see if things look right. In my case, it didn't, and it was a really easy fix. My formula was just not properly applied to the entire column. So what they've done over here is they just changed all these negative values to 0 because what were we told? You're not allowed to stay there anymore once the cost reaches 0. And somewhere between the 5th and the 6th night, my cost hit 0. Hopefully you guys can see that. All right, what's the next thing we've got going here? Um, option 2, where does it say? Option 2, per person. The cost is $240 the first day. Then it decreases by $30 every day. Well, that's easy enough. I'm just going to copy this little column here. Or I could actually just leave that. Let's just call this cost 1, and this will be our option 2. Call it cost 2, just since I already put the word cost there, and cost 3. All right, so cost 2 is what? Say that again. $240 for the first day. So 240, uh-oh. These are all 0, aren't they? We didn't really need a day 0 because it's kind of senseless, but it's already there, so it's not going to hurt anything. All right, so we had on the very first day was $240. And then, oh, I see what's happened. I'm working the example now. That's okay, you guys. All right, so $240 for the first day. And then what? It decreases by $30 every day. So that means that it is going to be $240, whatever that price is, minus $30 per day. So that's 30 times the number of days we've been there. So after the first day, we stayed there 1 day. So that's going to be times this number. I like following the example now because I can actually see that I'm right as I move along. And if you guys do this, you can do the same thing, because then it's real easy to go back and actually change your numbers for the problem, which we can even do that here together. All right, so I have that 210. Now I want to apply this all the way down. Looks good. Did I get the same thing they got? They got 150. How did I get down to 60 here? So they went 210 to 180. So let's just see what we did. All right, so I'm going to pause the video real quick and figure this out. Okay, I see what I did. What happened here is this worked because I used the 240 because it was the original day minus $30 per day. But then when I applied it to each cell below, now it's selecting the cost of the day before, and it did not say that it decreases by $30 each day minus how much it was the day before. It doesn't say anything like that. So my problem is that I needed to lock this 240 in, because it's going to be 240 minus $30 times each day. All right. So once I lock that 240 in there, you could also just type 240, but if you type 240 and then you go back and do your problem, and then you have to change every single number. So it's better to just lock your cell. All right, and then I just double click, and now I have all the same numbers. I love it when I make mistakes and I get to go back and show you guys how to fix those things, because we all learn more from each other's mistakes if we're smart and we listen. All right, let's look at day 3. Per person, the cost is $400 for the first day, and then in each successive day you subtract 10 times the square of the number of days that you've been there from the previous day's cost. All right, so from the previous day's cost, I used that in scenario 1 and 3. But when I tried to apply that to scenario 2, it didn't work, did it? All right, so here we started off at $400 for the first day. And then each successive day, all right, so each successive day, it was, in each successive day, you subtract minus 10 times the square of the number of days you've been there from the previous day's cost. It sounds like what I've already done for cost 1. Okay, so all that's happening here, you guys, is the fact that in my actual problem, option 1 is option 3 in the example. So It's no big deal. I've just already done that one. So I am going to do this other option here. If you guys are totally confused right now because the example and the problem have the same things in different orders, then please just look at it again. All right, I'm just trying to delete these things, clear these contents. And right now, I'm just going to find the scenario I don't yet have. All right, so I have, the first one is 600 the first day. I don't have that. 300 the second day. All right, so this one is $300 for the first day. Is that what it said? No, I'm sorry, 600. Sorry guys, I'm getting tired. 600 for the first day, 300 for the second day. And then what does it say? And in general, every day is half as much as the previous day. All right, so I'm actually going to delete this 300 and apply my formula here. So this equals half, that's 0.5, half of the previous day. All right, and I'm just going to apply that formula all the way down. All right, now, what is happening here? Well, what does it show in the example? In the example, they go down to 17 days to where it's a 1 cent a day. All right, so let's see, what is it asking us now? Which option is the best if your primary goal is to spend the least amount of money? All right, let's get back to our problem. That was the example. I'm going to show you guys how easy it is. You can follow the example, make sure your numbers are coming out correctly, which ours were. And now I'm going to go back to my actual problem. My actual problem, my actual scenario here says the cost was 400 the first day. Each successive day you subtract 10 times the square. All right, that's what I've actually already done that here, right? Remember, minus 10 times the square of how many days you'd been there. And then option 2 in this scenario was $240 the first day, and then it decreases by $30 every day. Yay, that's already what I've got here. And then the third one was that it $600 for the first day, $300 for the second day, and so on. So it looks like I'm all set up here. I'm going to go ahead and do what the example did. And everywhere I have a negative cost, I'm going to type in a 0. And then I'm just going to apply that 0 everywhere there's a negative number. All right. Whoops. 0. I'm sorry, you guys. I just wasn't sure. Did I make a mistake there? All right. So now I'm just trying to get 0 in all of these cells. Oh, I see, because that is 0. So I have to type 0 here. There we go. All right, and then you can see on this third one, I never hit 0, did I? But what I am going to do is I'm going to get rid of some of these decimal values. To get down to the tens place, eh? All right. Well, that's good enough. Okay, so now what is it asking us? Which option is the best if your primary goal is to spend the least amount of money? Well, look at this. All you have to do is total each of these columns. Go to your editing, auto sum, and auto sum each of these items You might be able to select all of these and do it all at once. I'm pretty sure you can. Okay, so the least amount of money here looks like it's going to be option 2. And you would spend blank, you would spend 1080. And how many days can you stay? It looks like you can stay for 8 days. You see that? Because on the 9th day, you're down to 0. It might be that you can stay 9 days. I'm not really sure. I'm just going to try it. If it says I'm wrong, I'll try 9. But it says I was right. And then which option will be best, blah, blah, blah. Okay, so you guys have all of these different scenarios. Another thing that you can do here, I think, is that you can select this data. I'm not really sure this is going to work out all at once, but let's just see what happens here. All right, we get some different graphs. But these are not actually the exact good graphs that I'm looking for. If we graphed each set of data separately, we would actually get something that does not look right. But I am not going to try to deal with that right now on this particular video. We will actually be doing this one on our Excel reports. So if there's something wrong with this right now, you guys can look at that. But I am going to move on to the very last problem. It's only going to take us a second. I just want you guys to see how easy logarithms are to do on Excel. And this is going to be number 39. We'll look at those graphs on number 37 when we do our Excel report. But I just want to get you guys started using Excel for your homework. 50 extra credit points. I hope you choose to do it. All right, number 39. I guess I'm just kind of thinking if I show you number 38, it's way too easy. 39 was just a little tiny bit more complicated, so I'm going to show you number 38 actually, and then I'm going to sign off and let you guys follow the instructions for number 39. The hard part is the part I'm about to show you. The easy part is solving. So look here, if I want to do a log in Excel, I simply type in log equals log, find it, double click. The number is always the big number. In this case, it's 1800. And the base is 5.75. And then I simply get my value. It wants me to round to 1 decimal place. I can round it myself, or I can let Excel round it for me. I had a student today who's like, Ms. Benzie, I don't do that. Excel does it for me. That was Griffith. All right, so here we have 4.3. Check my answer, and voila. Folks, number 39 is the exact same thing. Just have a look at it. And you're just going to divide by 5, and then you're going to apply a log to each side. Once you look at the example, it won't be terribly difficult. All right, I guess this one, because I didn't finish it, but you guys can finish that number 37. All right, I'm signing off. I hope this helped. Use Excel to do your homework, folks. 50 extra credit points. You got this. You guys keep being amazing. You rock.